Okay. Well, your homework was pretty fun. Your homework was pretty fun. Questions? I wore a blazer. Did you notice? So I was trying to be all professional. I remembered. But I mean, I also wore a Stormtrooper sweatshirt, so what are you going to do? Huh? Yeah, I like it. It's still hot and stuffy in the storage room, in case you're wondering. So, questions? Just the last one?
I mean, like, in this last lesson that we had to do.
Oh, okay.
But I think there were a couple
Yes.
Mondays.
Let's do it. From 2-6, 7, 2, 7, 6. I'm ready. Did you find one?
I don't remember which one it was, but it was either 53 or 55 that we did. Oh, wait.
55? Okay. I actually was asking my boss about that one because I'm like, I don't understand. I keep getting n prime. And apparently, I just don't know anything about science. So, because n is a constant, because of the law of conservation of mass, you can't ever change the amount of moles that you have in a system. So, n is a constant. I don't even know. So, 1, 0. Yes. It would be 0. Not even n prime. Yeah. So, you have p plus n squared a over v times v minus nb equals nRT. So let's FOIL this out. PV minus PNB plus n squared a. Is this supposed to be v squared? Yeah. N squared a v over v. And then minus n cubed a b over v squared equals nRT. Everybody follow so far? Excellent. I feel much happier today that I am professional. Okay, so let's differentiate. And we're differentiating the change in pressure with respect to time? What is it? No, change in volume with respect to pressure. Correct? Yes. Okay. So, what is dV over dP? Okay, so this is going to be PV product rule. So you have the first times the derivative of the second plus the second times the derivative of the first. But because it's with respect to P, it's just 1. So anticlimactic, erasing my dot. Minus, this is a constant, except for the P. Constant. Yay! Slash NB. Because the derivative of P is 1, and then the NB. Okay. Plus, this is the same thing as n squared a v to the negative 1. So we have negative 1 n squared a times v to the negative 2. And then this is n cubed ab, v to the negative 2. So we're going to bring this negative 2 in front. That's going to become a positive, plus 2 n cubed ab, v to the negative 3 equals 0. We don't even need to use the chain rule. Okay. So PV prime plus V, and then minus NB minus N squared A over V squared plus 2N cubed A B over V cubed equals 0. Everybody's good. Me too. Okay. Then we're going to solve for this one, right? So we're going to move all the stuff. So PV prime. What do I do next? I'm just referencing my notes. Oh, here. Oops. Times V prime times V prime. We did need to use a chain rule. I was just freaking out for a minute. Okay, because we took the derivative of V. So, and because it's with respect to P, we needed to do that. Okay. Now, okay. So, V prime equals 0. Okay. So, this right here, we're going to move because it doesn't have a V prime in it. So, factoring out V prime, we have P. This is over there now. And then minus N squared A over V squared plus 2N cubed AB over V cubed equals NB minus V. So, common denominator. So, we're going to have V prime times PV cubed minus N squared AV plus 2N cubed AB over V cubed equals NB minus V. So multiplying both sides by the reciprocal of this, we get that the derivative is V cubed times NB minus V over PV cubed minus N squared AV plus 2N cubed AB. Isn't it beautiful? The suspense is over. We know how to do it. All because that stupid N is a constant. And actually, in part B, N is 1. So it's even simpler. Because N is 1, B is 10, P is 2.5, A is 3.592, and B is 0.04267. Plugging that all into your calculator, you get that V prime is negative 4.0404903334. Yeah! Did it! Liters per atmospheres. I'm sorry that I know nothing about science and that I missed that super important and significant detail. We had a good laugh at me, though, if that makes you feel any better about how I know nothing about science. I did, just in case you're wondering. Like, I took AP Bio and AP Chem and AP Physics C, which is when it's calc-based. But forgot it all. Replaced it with things like Lord of the Rings quotes. So, do you have a question, Sam?
Actually, I do. Why did you take AP Chem?
Oh, I don't know. Well, I was doing IB. Do you know what IB is?
Yeah.
So pretty sure I had to take all of the APIB science classes. We had to do this big thing called the Group 4 project, where they gave us, so, I don't even remember, it was something about water. I don't remember, but ours, you had to analyze something from all three perspectives, biologically, chemically, and physically, like something. And so we had water. And I remember sneaking onto the golf course at night in all black to get a sample of the golf pond water. Yes, I would be like, I was like singing. My grandparents lived on the golf course, so I just got to like go through the gate. It was really anticlimactic. I'm just like, now I was on the golf course because that was their backyard. And so, but I stood like, and one of the families trick or treating last night was The Incredibles. It was so cool. It was so cool. Okay. Yes. What was the other one that we were working on Monday that I didn't get? 61? Okay. I've got that one too. Dang it, I lost an, oh no, there it is. Okay. 61, yeah, this one is so much easier than I thought it was. Okay. So 61 says xy double prime plus y prime plus xy equals 0. Okay, and j of 0 equals 1. Okay, so if we plug in 0 for x and 1 for y, we get that x 0 times y double prime plus y prime plus 0 times 1 equals 0. Right? So y prime equals 0. Okay, well if we plug that back into here, we're just going to get 0 equals 0, which we know. So it doesn't help us to actually solve for y double prime. So let's differentiate. So we get, let's use the product rule, x times the derivative of y plus y double prime times the derivative of x, which is just 1, plus y double prime plus x, product rule, x times the derivative of y plus y times the derivative of x equals 0. And then let's plug in everything we know. 0 times y triple prime plus y double prime plus y double prime plus 0 times 0 plus 1 equals 0. 2y double prime equals negative 1. Y double prime equals negative 1 half. So much easier than I was thinking. Do we have any other questions? Because I'm on fire today.
Yes.
Okay.
34.
35. Do you need this? Okay. What does 35 say? X squared plus 4y squared equals 4. Did it ask us to solve for anything or just y double prime? Okay. So 2x plus 8y times y prime equals 0. So 8y times y prime equals negative 2x. So y prime equals negative x over 4y. So then y double prime equals 4y, negative 4y, times, well, let's make the x negative. The derivative of the first minus x, so plus because x is negative, times the derivative of 4y, which is 4y prime, over 4y squared equals negative 4y plus x times 4x times y prime over 16y squared, but y prime equals x minus 4y. So y double prime equals negative 4y plus 4x times negative x over 4y over 16y squared, which equals negative 4y, negative 4y minus 4x squared over 4y over 16y squared, which equals negative 16y squared minus 4x squared over 4y over 16y squared equals 4y squared minus x squared over 64y cubed. Is that the answer? Oh, my 4y is supposed to cancel somewhere. Except for 4y. Oh, I substituted. Did I? Dang it. My on fire roll is having a momentary pause while I try to figure out what I was doing. Y times y double prime. Where am I getting that? Oh. I know where I'm getting at. I'm going to differentiate this again because it's easier. 2 plus So far, so good. All right, product rule. 8y times y double prime plus y prime times 8y prime equals 0. So 8y times y double prime plus y prime times 8y prime equals -2. Divide everything by 8. Y times y prime plus double prime y prime squared equals -1/4. And now I'm going to plug it in that thingy. Still on fire. Sorry, that's my flames. Okay. So y times y double prime plus -x/4y squared equals -1/4. So y times y double prime plus x squared over 16y squared equals -1/4. So y times y double prime equals -1/4 minus x squared over 16y squared. So y times y double prime, need a common denominator, it's going to be 16y squared. So this becomes 4y squared, -4y squared minus x squared over 16y squared. Multiply both sides by 1/y. Y double prime. Am I getting the same thing? Let's see, 4y squared over 16y squared times 1/y is 1/4y minus x squared over 16y cubed. Is that the answer? No? Because here I multiplied, so I actually made a mistake here. Let me start from right here again. Okay. So then y times y double prime equals, I'm just going to leave it as this. We are into 6:35. Oh, did they substitute in again? I don't think I made a mistake. Do you see one? I think it's probably just a matter of simplification.
I looked up the answer and somebody else did it completely differently.
Well, with calculus, there are multiple ways to do stuff. How could you do it completely differently if you're just differentiating twice?
I think he did, he or she. I can show you the picture. I think he did it like the first one. He substituted x squared plus 4y squared equals 4 after he factored that out.
Okay. We could do that. Let's try that. Let's start from right here. Let's switch colors. Okay, so let's differentiate this again. So you get y double prime equals, you have the bottom times the derivative of the top, which is -1, which is negative x, minus the top, negative x times the derivative of the bottom, which is 4y prime, over 4y squared, which equals -4y plus, and then we have x times -x over 4y, substituting this back in, over, that's 4 as well. Oh, maybe that's where I made my mistake. Because I didn't have another 4, I couldn't cancel it out. Because the 4's would cancel out, and you're just left with the -x squared over y. Over 4y squared, which equals -4y minus x squared over y over 16y squared. Getting a common denominator, we have -4y squared minus x squared over y over 16y squared. Factoring out a -1 gives me 4y squared plus x squared over 16y cubed, which equals, this is this, -4 over 16y cubed, which is -1 over 4y cubed. I should pick that up. I lost my cap. Did anybody see where it went? Because I just got very satisfied and threw it on the ground. I'll find it at some point. Ew, what is that? It looks like poo in the trash. I can't find it. Oh well, small price to pay. Okay. Oh. How do you feel about that one?
Glad that it's
Yes. So it was equal to the same thing that I got before, unless I don't remember whether or not I kept that 4 there if I substituted without it. I probably, because I didn't see a mistake and I was looking at it, so we'll find out. We have a tape of it. So it was just a matter of simplification. Where could it have gone? Seriously. I didn't see it. I just saw something that looked like poo. I don't know. Okay. Any other questions? Okay. Which one? 39. I was doing this in between trick-or-treaters. All my trick-or-treaters stopped by like 6:30.
Really?
Yeah, I was so disappointed. And kids suck. I don't mean to say that negatively, but they would come up and I would be like, do you want a prize or do you want some candy? Because I was trying to be sensitive to food allergies. I was trying to be a good, trick-or-treat. So they would be like, ooh, prize! And then they would look in it. It was like pencils, and I had one of those little mazes with like the ball. And I had like mustaches and what was the big thing? Oh, I little prizes, like ribbon prizes that said like scariest costume and funniest costume, and they would look at it and they'd be like, candy. What? And at one point, I had just like all the gobstoppers had risen to the top, so that was all you could see. It was just a bunch of everlasting gobstoppers, and it was this group of like 3 kids, and I had a lot of repeats, and I recognized them, and I would be like, huh. But anyway, so they would come up and they'd be like, I'm just gonna save that for the other kids. It's
Seriously?
free candy, you little brat! I paid for this! Yeah. That happened a couple of times. And then one kid walked up with his dad. I was sitting out front because we have a really family-oriented neighborhood on base. You're only allowed to live in those neighborhoods if you have a family. There's no diversity. It's just all families, right? And everybody is almost the same age because you can't enlist past a certain age. And so almost everybody is like the same. So everybody sits on their driveway, and I had been sitting in the house doing this, and eventually one of my friends came over, and she's like, oh, well, maybe you don't have anybody come in your house because you're not sitting on the driveway. So I went, and I was sitting there, my garage door was open. This kid walks up with his dad and said, oh, Dad, they're Raiders fans. And they wouldn't come up. Like, what the heck, man? I'm sitting here with a rocking chair dressed up like Indiana Jones with a big thing of candy. I'm clearly nice. Like, what's up? I don't know. I'm still really bothered about this cap situation. Is it like just next to something they can't see? I really should have double thought throwing it on the ground. Oh well, I have to go to Target today anyway. I'll just pick up a new marker pack. I'm pretty upset about losing my purple one. Okay, so 39. If xy plus y cubed equals 1. Find the value of y double prime at the point where x equals 0. What is y when x equals 0? Right? So, differentiating the first times the derivative of the second plus the second times the derivative of the first plus 3y squared times y prime equals 0. So, let's see, x times y prime plus 3y squared times y prime equals negative y. Y prime times x plus 3y squared equals negative y. Y prime equals negative y divided by x plus 3y squared. Y prime equals negative 1 over 0 plus 3 times 1, which is 3. So y prime equals negative 1/3. I haven't gotten that far yet.
Find the value of y double prime.
Oh, I know. I'm not done. I was just stopping to make sure that you were. Okay, you ready? Okay, so y double prime equals, using the quotient rule, x plus 3y squared times the derivative of negative y prime, minus negative y times the derivative of the bottom, which is 1 plus 6y times y prime, over x plus 3y squared. Okay. Y double prime equals 0 plus 3 times negative 1/3 plus negative, that's a y, 1 times 1 plus 6 times negative 1/3 over 0 plus 3 squared, or 3 times 1 squared, it's just 3 squared, equals 3 times 1/3 plus 1 times 1 minus 2 is negative 1. Supposed to get a positive 1 somewhere. So 1 minus 2 is negative 1. Is this supposed to be negative? One of them is supposed to be negative. Where did my mistake?
Y prime is negative 1/2.
Is this supposed to be negative? Yes! Because the quotient rule. Over 9. What number is this? 39. I didn't square that. Negative y prime. Okay. Minus negative y. Oh, I made a mistake there. That's 1/3. 6 times 1. Negative 1/3. I'm guessing the answer is not 0.
I think it is 0.
Oh, really? Oh, well then that's 0. 0 over 9 is 0. There you go. I made a mistake when I did it. I thought for some reason I substituted y prime instead of y right there. And so it gave me negative 8/9 as an answer. That was a mistake. A trick-or-treater probably came up in the middle of it. Does that make sense? Good. Any others?
Yes.
Okay. Which one?
Number 43.
43. I'm just going to keep using this color before it dies. Find the point on the lemma skate in the exercise 31 where the tangent is horizontal. So 2. You did 31, okay?
Yes.
Okay. Because I'm just going to take the derivative from there.
Yeah, I wrote the derivative of that on the whiteboard and then I erased it and then I didn't put it in again, and I think I just gave up.
I'm sorry. Do you want me to do the derivative now then?
No, it's okay.
Are you sure?
Yeah.
Because it's
But if you have the derivative, that's fine.
I have it all written down. I'll just do it. Okay. Did I write this whole thing out right? Yeah. Okay. So the derivative of this is going to be 2 times 2x squared plus y squared to the first times, using the chain rule, 2x plus 2y times y prime equals 25. So this became 25x squared minus 25y squared. So equals 50x minus 50y times y prime. So 4x squared plus y squared times 2x plus 2y times y prime equals 50x minus 50y times y prime. So then this is 4, well, let's not do that. Let's do it this way. 2x times x squared, and then plus y squared plus 2y times y prime times x squared plus y squared equals 50x minus 50y times y prime. Divide this over here. 25x, 25y over 2. And then this can go away. So subtracting this over here, 25x minus 25y times y prime over 2 minus 2x x squared plus y squared equals 2y times y prime times x squared plus y squared. Good so far? Okay. And then I'm just going to divide both sides by this so that I get y prime equals, let's see, 25x minus 25y times y prime minus 2x. Oh, I needed that on the other side. Sorry. It started to feel familiar, and so I just started to, like, zone out. Okay, so starting from here. All right. So I've got 4, 8x, 8y. 4 is gone. Okay. So I have 8x times x squared plus y squared plus 8y times y prime times x squared plus y squared equals 50x minus 50y times y prime. I'm going to subtract this over here and add this over here so that I get 50y times y prime plus 8y times y prime times x squared plus y squared equals 8x times x squared plus y squared plus 50x. Okay, so factoring out y prime, 50y plus, oh, sorry, I was automatically jumping ahead to divide everything by 2. 8y times x squared plus y squared equals 8x times x squared plus y squared plus 50x. So then y prime equals 8x times x squared plus y squared plus 50x over 8y times x squared plus y squared plus 50y. Dividing everything by 2 gives me 4x times x squared plus y squared plus 25x over 4y times x squared plus y squared plus 25y. That's the derivative. Make sense? Okay. Did I make a mistake? Is that what you're looking at? Okay. So, zero equals 4x times x squared plus y squared plus 25x over 4y times x squared plus y squared plus 25y. Because we're looking for the places where the tangent line is horizontal. So, that's gone. 0 equals 4x times x squared plus y squared plus 25x. 0 equals 4x cubed plus 4xy squared plus 25x. Going back to the original, what do I do? I know I plugged something in. What number are we doing? 43. Oh, that's what I did. I didn't do that. Factored out an x. And that gave me 4 x squared plus y squared plus 25. Okay. And then, using my zero product property, either one of these being 0 is true. So x can be 0 or 0 equals 4 times x squared plus y squared plus 25. So then negative 25 over 4 equals x squared plus y squared. How did I get rid of my y? Oh, I didn't. Where did I get that? 2 times 25 squared. Oh, I substituted. 2 times negative 25 over 4, because this is x squared plus y squared. So is this. Equals 25 times, where did I get x squared minus y squared? I left it. X squared minus y squared. So then negative 25 over 2 equals 25 times x squared minus y squared. Divide both sides by 25. Negative 1/2 equals x squared minus y squared. Oh, I got 25/8. Did I get 25/8? Oh, wait. Oh, because this was squared. Squared, 2. So then 2 times 625 over 16 equals 25 times x squared minus y squared. So then this became 8. Divide both sides by 25. and that becomes a 25, because 625 is 25 squared. 25/8 equals x squared minus y squared. And from there, I had a system of equations. 1 and 2. So stacking them on top of each other, I get that x squared, 2x squared, equals 25/8 minus 25/4, which is, wait, which one was supposed to be negative? Oh, that means subtracting that equation. Okay. And then 25/16. No, 25/8. It's supposed to be 25/8. I don't remember where I lost a negative. Did you see it? So then x squared equals 25/16. So x equals 5/4 plus or minus. And then taking this, plugging it into this one. So x squared, 25/16, plus y squared equals 25/4. I think that one's supposed to be positive. I think that's where I messed up. So y squared equals 25/4 minus 25/16, which equals 75/16, which means that y equals plus or minus 5 rad 3/4. So my 2 points, well, that's it. Make sense? Does it make sense?
Yeah.
Okay. Lots of back substitution. I like to ease like my Algebra 1 students into the idea that once you get, the higher up you go, the less review there will be, because you're just expected to remember everything that you've ever learned about math and then recognize when you can use it. So, but it's fun that way because it's so creative and you get to do all kinds of things. People think math is formulaic and just like plug this in and plug this in and simplify, but you have so much creativity in calculus. There's multiple ways to do almost every single one of these problems. Isn't that encouraging? Okay. You're doing well, I think. Sam's number 1. So is Avery and Sid. Okay. Any others? Really? Man, my homework was a doozy, wasn't it? So last night's was kind of a break. Good. Today is going to be super fun. So if that's it for homework questions, pass it in. Today we're doing related rates. And I have had an interesting experience today, recognizing that Praxi deleted everything in my lesson plans and my grade books, because it started saying there's no school on every day, and so none of it is a valid grading period, so it didn't save any of it, which is weird because I could access it for several weeks, and now it's just gone. So I'm going to have to wait until that gets figured out and then start from scratch. But in the Algebra 2 class, we started a Google Classroom class. Do you guys want to do that? And I can like post assignments there and stuff, and you can see your grades. And you want to do that? Okay, we'll do that. And then there's Avery's. Yay! Okay. I was eating chili, I think. Sorry, I didn't need to point out the food stain in my book. I don't know why I felt the need to do that. It was so pretty when I ordered it. So. Okay, so let's start off with the problem that looks impossible. Right? If we are pumping air into a balloon, both the volume and the radius of the balloon are increasing, and their rates of increase are related to each other. Because of course they are, right? The radius expands, which means there's more volume. That's how it fills up. But it is much easier to measure directly the rate of increase of the volume than the rate of increase of the radius, because it's a three-dimensional object. Yes, okay. And related rates, the problems, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity. So then you find an equation that relates both of them, and you differentiate both sides using the chain rule. So, example. Air is being pumped into a spherical balloon. So, see, even though we're in calculus, they still have to make it hypothetical so we can do it. So it has to be easy. It's a perfect sphere. How convenient. Okay. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 centimeters cubed per second. And it's a perfect sphere. Wait. Can you do that? Like that. That's actually not bad. Okay. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? 50-meter balloon. That is so much bigger than your standard hot air balloon too, isn't it? I don't know. I have no idea. It's 150 feet-ish, which is still only like half, 2/3 of a football field. Half of a football field. No, I don't know. Blanking out. A minute. Yeah, it's 300 feet, so it's half. Yeah. For some reason, I started to feel like it was 300 yards, but it's not. And that was like, wait, that's 1/6. Okay. So, how do we do this problem? Ah! Okay, so what do we know about spheres? Well, we're talking about the volume. So the volume of a sphere is this. We're talking about the rate of change of the volume. So derivative is a rate of change. So dv dt is 100 units. Okay? And we want to solve it. R is going to be 25, and it's asking us for dr dt. Because it's asking us for the rate of change of the radius. That make sense? Okay, so let's differentiate. So dv dt equals We're going to bring down R3. We're going to get 4 pi r squared, and then dr dt. But we already know 2 of those things. So dv dt is 100 times 4 pi, r is 25, r squared times dr dt. So solving for dr dt, because that's what the problem is asking us, dr dt equals 100 over 4 times 625, which is 2500, and then pi, which equals 1 over 25 pi. So that's how fast the radius is changing. dr dt equals, remembering our units, 25 pi centimeters per second. See, that's not so bad. Are you looking to see if it gets worse?
Because my friend, he's taking AP calculus,
Yeah?
and he's like, oh, so you're taking calculus, what are you going through right now? And it was like a couple weeks ago. Maybe like a week or so. I'm going to the general. He's like, oh yeah, wait till you get to related rates.
That's not, no, this is not that bad. It's not that bad. The only thing that you have to worry about is coming up with the information that's not given. But like I just said a few minutes ago, you've already learned it. And you are definitely held responsible for everything you've learned in math. So all you have to do is try to piece together relationships between what's going on in this problem. Does that make sense?
Yeah.
Okay. So, like, this one was not that bad, right? Right. I mean, I know I'm here to like be like, this is what you do next. And so it seems a lot easier. But let's do another one. Okay? I almost don't want to erase my perfect sphere. Huh? It looked really good. It really did. Okay. Example 2. A ladder 10 feet long rests against a wall against a vertical wall. If the bottom of the ladder slides away from the wall at a rate, so this is sliding, so this way, 1 foot per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Okay, so this is going to be 6 feet. And it wants to know, let's call this y, dy dt. And we know that this, because this is going to be our x, this would be y. This is dy, dx dt. Ah. So, what's that? Yeah. And what do we know about those? But we already know x, right? That's 10 squared. So, y squared equals 100 minus 36. Y is 8. Let's differentiate. Okay, so you have x squared plus y squared equals 100. So 2x plus 2y times dy dt equals, oh, with both respect to time, so we need to use the chain rule right there. 2x dx dt equals 0. Don't forget about the respect to time thing, because then you would miss this. And that's going to change the whole problem. So, yay! Respect to time. Okay, so think about what we know. We know, see, x is 6. You know, dx dt is going to be 1. And we're looking for dy dt. So let's solve for dy dt. So 2y times dy dt equals negative 2x dx dt. Dividing both sides by 2y, we get that dy dt equals negative x over y dx dt. So let's plug in everything that we know. Oh, I forgot. Y equals 8.
The y be under dx dt
No. Because I'm multiplying by 1 over 2y. Just once. So I'm going to put this right here. But very good question. Yeah. Okay, so plugging in the information we have, dy dt equals negative 6 over 8 times 1, which is negative 3/4 feet per second. That's it. You look so suspicious. Not that bad. Right? Yeah. This one isn't. Okay. So let's do another one. Do we have time to do? No, we don't have time to do all of them. A water tank has the shape of an inverted circular cone. With base radius 2 meters and height 4 meters. If water is being pumped into the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 meters deep. So what shape is this? It's a cone. And we're talking about the volume, because it's water and space and stuff. So what's the volume for a cone? I'll give you a hint. Because this and this are not the same, but it's three-dimensional, it's the exact same thing as the volume of a cylinder, except we have to divide by 3. Because this is smaller than this. Same thing's true for a pyramid and a prism. Cool. But let's put that out front so that we can identify it as a constant. We already know we're going to be end up differentiating. Okay, so if this is how fast water is being pumped in, that is the rate of change in the volume, right? So that's dV dt. This is what our height is going to be. We know that our radius here is 2, but what's our radius here going to be? Because as you can see, it's definitely not 2. So let's just take that shape out for a second and think about how we're going to possibly solve the issue of how to deal with this R. There's 3 variables over here, V, R, and H. We're looking for H, right? dH dt. That's what it's asking us. Is it dH or dr? I don't even remember. The rate at which the level is rising. So dH dt. So R is completely unhelpful. So we're going to get rid of it. We need to think about how we're going to talk about R in terms of H. So these are similar triangles. So 2 over 4, so the base to the height of the first one, or the radius of the height, is the same thing as the radius to the height of the other one. So let's just put that as 2h. So you want to get a more of a generic term. So we're going to have 2h equals 4r, or r equals h over 2. Does this make sense? So the volume equals 1/3 pi h over 2 squared h. So volume equals 1/3 pi h squared over 4 times h, which is pi over 12 times h cubed. That's a lot easier to differentiate. Yeah. So let's do it. dV dt equals, bringing this 3 down, and it's going to cancel out with this, so we get pi over 4 h squared dH dt. Let's solve for dH dt since that's what it's asking us for. dH dt equals dV dt times 4 over pi h squared. And let's plug stuff in. So dV dt is 2. 2 times 4 over pi times 9. 8 over 9 pi. Meters per minute. That's it. Have I quelled your fears? You want to do a hard one? Okay. Example 5. Always want to make something harder. Bring in trig. Just kidding. I love trig. Trig's my favorite. Verifying trig identities is my favorite math thing to do. I love it so much. It's not even like I hate it less than other things. I love it. I get so excited when students come in and they're like, "Ah, I'm verified trick identities." Like, yes, let's race. I get so excited. Okay. So, example 5 says, a man is walking along a path. Hey, dude. He's walking. And he's French. Okay, so, bonjour, Sam. Okay, so he's walking along 4 feet per second along this path, 4 feet per second. A searchlight is located on the ground 20 feet from the path. Not bad, huh? I mean, if you know what it is, that's good for me. Okay. And is kept focused on the man. So, at what rate is the searchlight rotating? So, how is it moving when the man is 15 feet from the point on the path closest to the searchlight? Well, it's postulate in geometry that any point, the minimum distance between any point and a line is going to make a perpendicular intersection. So we know that the shortest distance, this is a right angle. And if he's 15 feet away from there, let's do some math. 20 squared plus 15 squared equals x squared. Actually, I don't even know if we need to do that. Let's hold off on that. This is theta, right? We want to find d theta dt, because that's what it's asking us. We already know, let's call this x instead. I don't even know if we'll need that. So, we already know that dx dt is 4. We already know that x is going to be 15. So, let's think about what we know. Compared to this angle, we know it's 15 and 20. We know that the tangent of theta is 15 over 20, which is 3/4. So, tangent of theta equals x over 20, since 20 is constant, and we're looking for this. So, secant squared, differentiating theta, d theta dt equals dx dt times 1 over 20. So we're looking for d theta dt. Let's solve for it. So d theta dt equals dx dt 1 over 20 times the reciprocal of this, which is cosine. We do need it. Because cosine is adjacent over hypotenuse. We don't know the hypotenuse yet. So let's find it. It's going to be the square root of 15 squared plus 20 squared, which is the square root of 225 plus 400, which is rad 625, which is 25. It's a Pythagorean triple. 3, 4, 5. So, d theta dt equals 1 over 20. dx dt is 4 times 4, and cosine of theta is adjacent over hypotenuse, so it's 20 over 25, which is 4/5 squared, so equals 1 over 5 times 16 over 25, which equals 16 over 625. That's it. Not bad, I think. What do you think? Lots of head motion, Sam.
Yeah. It says it's 16.
Oh, it is. Sorry. 5 times 25 is 125. Not 25 squared. 125 times 5 is 625. Thank you. Okay? Yeah. Good. So let's make up some homework for you since I lost all of your assignments. I didn't. Praxi did. Actually, why don't we do this? Why don't I look at these again and try to figure out which ones are going to be like ridiculous stupid and avoid those, and I'll email you your homework or I'll invite you to Google Classroom, and then I'll post the homework there later today. That way we don't have to do one of those of, why did I assign you this thing? Okay? Because it was planned out, it's not there. I was so disappointed. I had the entire year for Algebra 2 and for Ancient History on there. That's okay. Remember how I said when you walked in I wasn't having the best day because I had to like be an adult in my Algebra 2 class, and I learned about that, and people were coming in trying to get the balls and moving the whiteboards and stuff, and I was just sitting there like, I can't cry in front of these students. They can't see me break. I was so upset. And I feel much better now, as a side note. So I already dealt with my feelings about the Praxi stuff losing everything. It is what it is. It stinks, but we'll make do. Okay. So no other questions about this? Okay. That's it. Don't let your brain trick you into thinking that it's hard. Because sure, everything in calculus is hard. But you just got to take it one step at a time. The hard part is figuring out what the steps are. But you got this. They're not going to ask you anything you haven't learned. I need to find my cap. Disappeared. Oh. Bye, Sid.